Space is being invaded by very large swarms of very small satellites.
It's sometimes referred to as Space 2.0 or New Space or really a space revolution.
Within a decade, thousands of these low-cost cube satellites, CubeSats as they're known, will be deployed.
The amount of things you can do with those satellites is huge.
They'll image every corner of the Earth, every day, explore the Moon, Mars and asteroids, and help us understand the near-Earth atmosphere like never before. For the first time ever, anyone with a bright idea can launch it into orbit.
CubeSats. Dynamic power and SWaP reduction in CubeSat systems. CurrentRF reduces dynamic power and CubeSat architectures with our patented circuit noise activated CC100 power optimizer silicon supercapacitor IC.
Dynamic power dissipation. What is it and why is it important? Dynamic power is the power draw from system power supplies, generated by the current, created by logic and switching circuits changing states. This type of power dissipation is the primary source of power draw seen in microprocessors, memory, transmitters, etc. Dynamic power is usually included in, and not broken out, in the total power consumption listed in device data sheets. This oscilloscope shot demonstrates the supply line manifestation ripple of dynamic power and current draw from digital and switching circuits on our CC100 evaluation board. The vertical deflection of oscilloscope is set at 10 MV per division. The reduced magnitude voltage ripple conditions in the oscilloscope plot is the CC100 engaged condition, PowerStic inserted, which correlates to 202 mA on the DC meter in the video inset. The high magnitude voltage ripple condition in the oscilloscope plot is the CC100 disengaged condition, PowerStic extracted, which correlates to 210 mA on the DC meter in the video inset.
As mentioned in the oscilloscope video, CurrentRF's solution to reducing dynamic power dissipation is the CC100 PoSSC Power Optimizer Silicon Supercapacitor. Inserting our solution into CubeSats will result in up to a 36% reduction in system size, weight, and power, SWaP. The AC characteristics of dynamic power radiate through the system, causing RF interference, thus differing from the effects of static DC power, no radiation. Inserting our solution into CubeSat and other systems increases RF and analog sensitivity, allowing the system to perform at lower levels of signal input. The advantages of using the CC100 PoSSC IC in CubeSat systems are a 20% to 36% reduction in the size, weight, and power, SWaP, of the power distribution system and solar panels. Given the same dynamic power load in the system, or conversely more data processing, or increased transmitting capability in a given CubeSat system, given the same size power distribution system and solar panels with increased receiving signal sensitivity in the RF receivers and analog sensors.
Additional advantages of including the CC100 PoSSC IC in CubeSat and other systems are 1. Internal energy harvesting, up to a 36% reduction in dynamic current and power. 2. RF emissions reduction, up to a 36% reduction over standard DCAPs. 3. Enhanced power integrity. 4. EMI reduction, EMC improvement. 5. 2 times the small signal effective capacitance increase with respect to standard capacitors. 6. 600 times the large signal reservoir capacitance increase with respect to standard capacitors. 7. A 25% reduction in effective series inductance, ESL. 8. Enhanced system, PSRR, cleaner system spectral outputs. 9. Draws no operational DC power. 10. The CC100 IC and IP can be shaped into any form factor. 11. The CC100 is used as a standard bypass and reservoir capacitor. 12. Customizable design. The CC100 PoSSC IC and reference design has been embedded in a USB dongle, which we call the PowerStic. It has been found that the USB packaging does not change the CC100 PoSSC IC and reference design performance. Note that the data lines for normal USB operations are not connected to the CC100 PoSSC IC and reference design USB packaging. As one can see, The 10mm by 12mm dimensions of the CC100 POSSC IC and reference design fits easily in USB-A and USB packaging. Thus, all data presented for the PowerStic equally applies to the CC100 POSSC IC and reference design. Given the PowerStic to CC100 POSSC IC and reference design identity, the next performance video and material presented for the PowerStic equally applies to the CC100 POSSC IC and reference design.
What you're seeing is a demonstration of how the PowerStic saves power in systems. What you're actually seeing is PowerStic plugged into our demo board. We're actually measuring the power plane in two different ways. One is with the spectrum analyzer, the other is with the DC meter. As you can see, when we pull it, it jumps back up to 210 mils. When we plug it back in, the spectrum actually suppresses and it goes back down to 202 milliamps. The interesting thing to see here is as we pull, extract, and insert the PowerStic, we literally suppress these frequencies. It's also from 400 megahertz or so all the way up is the frequencies that hackers are actually going after to gain access to computer systems. We suppress those and deny them that access. The actual power here is the delta is about 1 watt when plugged into a 120 volt power line, the equivalent of a small server or a reasonable laptop, a 25 watt laptop, if you will. So that's how the PowerStic works. It literally harvests these high frequency noise energies, if you will, and feeds them back into the system as usable power, and it's reflected by DC drop across a regulator, across a 1 ohm resistor on our demo board. Very similar to what happens in any system.
The included AC coupled supply line spectrum plots show the noise spectrum generated by the pseudo-random noise generator on the CC100 evaluation board. In response to a typical noise spectrum plot of a standard 1 UF microfarad electrolytic cap, the blue spectrum plot, with respect to the CC100 POSSC IC, the green spectrum plot. The light blue delta plot at the bottom of the spectrum plot shows the noise delta given the 1 UF electrolytic capacitor spectrum plot and the CC100 POSSC IC spectrum plots. The plots clearly show the CC100 POSSC IC devices are superior in bypassing and eliminating broadband noise with respect to the standard 1 UF electrolytic capacitor used as reference, which is especially effective in eliminating noise in the 1 GHz band and above. The CC100 POSSC inductance cancellation is clearly shown in this plot, in that noise in the 1 GHz band are eliminated from the supply line. The CC100 POSSC IC reduces dynamic power and current, thus reducing the ability of the noise to couple into sensitive analog and RF sensors and receivers. The time domain plots for the output of an RF amplifier driven, subsampling track and hold. The track and hold driving an ADC analog to digital converter shows how CC100 POSSC device reduces dynamic power and noise, thus improving RF sensitivity. In this simulation, the CC100 POSSC inclusion, replacing typical on-chip bypass capacitors, improves system RF sensitivity by -3 decibels from 143 dBm to 146 dBm. The CC100 POSSC IC is easy to install in existing systems for prototyping purposes. The backside of the 10mm by 12mm printed circuit board that is used as a mounting platform for the CC100 POSSC IC has no solder mask, enabling solder attachment of the 10mm by 12mm printed circuit board directly to the ground plane of an existing CubeSat system printed circuit board. The procedure is to find or create a section of non-solder masked CubeSat printed circuit board ground plane, place and solder the CC100 POSSC IC and reference design printed circuit board into place, then connect the supply connections of the CC100 POSSC IC 10mm by 12mm to the supply line of the CubeSat system printed circuit board. The CC100 POSSC IC and reference design can be prototype attached into CubeSat systems. In this example, multiple CC100 POSSC ICs can be attached to any ground plane in any CubeSat system, in this case, a 6U CubeSat. In order to determine the most optimal placement of the CC100 POSSC IC and reference design in CubeSat systems, CurrentRF has developed hardware probing and analysis software that can assist the user in finding the most optimal location for CC100 PoSSC IC and reference design insertion. The analysis software can be utilized to spectrally probe, measure, and characterize the supply line noise environment of the existing PCB without the CC100 PoSSC inserted. Then measure the delta in circuit dynamic current and noise performance with the CC100 PoSSC inserted and operating. This activity will allow users to not only measure power reduction and sensitivity enhancement real time, but also aid in determining PCB changes needed for CC100 PoSSC IC system integration. The PowerStic, the CC100 PoSSC in USB packaging, can also be utilized to harvest and recycle coupled noise power existing at server and device USB ports. The shown methodology and analysis software was utilized at PayPal to show the power performance difference in the servers with and without the PowerStic, aka the CC100 IC, inserted. The same methodology can be used in CubeSat system prototyping. The CC100 PoSSC IC and reference design can also be utilized to save significant power in microprocessor and flash memory designs and operations. Data processing and storage is common in CubeSat architectures, and in this example of power reduction in flash memory, SD cards, a 2 mA reduction is shown in data transfer operations. The CC100 PoSSC IC and reference design can be utilized to save significant power in microprocessor and flash memory designs and operations. Data processing and storage is common in CubeSat architectures, and in this example of power reduction in flash memory SD cards, a 2 mA reduction is shown in data transfer operations. CurrentRF has developed a very true-to-life behavior model that can be built from common SPICE behavioral sources. The model represents the CC100 PoSSC IC and reference design behavior. It is meant to be utilized to replace the bypass and reservoir capacitors, utilized in PCB and IC designs. The model accurately represents the behavior of the CC100 PoSSC IC and can be utilized to set the design parameters of the device and IP to be imported and utilized in actual PCB and IC designs. Provided with the CC100 PoSSC IC and reference design behavior model is an example test bench, which can be modified by the user to more accurately model the electrical environment in which the CC100 PoSSC IC and IP will be operating. The purpose of these models is to give the potential buyer of the IC and IP a first look at what the technology can provide in terms of power and sensitivity enhancement in CubeSat and other systems. Example performance enhancements of what the user can expect to see from the CC100 PoSSC behavior model is shown both in time and frequency domain. A simple inverter-based clock tree was utilized to generate the example plots. More sophisticated digital circuits will generate waveforms similar to what has been shown in the presentation. Contact CurrentRF for more details. The applications are varied for the use of the CC100 PoSSC behavioral model. The model can be utilized to show digital power performance enhancements and also to show RF and analog sensor sensitivity enhancements. Contact CurrentRF for further details on any particular application. The CC100 behavioral model can be utilized to model the IC design in PCB systems, as well as to model a behavior in IC designs. Both levels of integration replace the bypass, reservoir, and DCAPs, decoupling capacitors. Again, contact CurrentRF for application details. CurrentRF has integrated the CC100 PoSSC IP into RF and ADC mixed signal designs. In this particular integration project, the CC100 PoSSC IP was utilized to replace on-chip decoupling capacitors in a very sensitive RF amplifier, subsampling track and hold, an ADC system on a chip, reducing dynamic power and increasing RF sensitivity from negative 143 dBm to negative 146 dBm. The CC100 PoSSC behavior model was utilized in this effort to set parameters for the CC100 PoSSC IP designs and import. CurrentRF has extensive trade show and customer demonstration experience. The company has developed and utilizes a portable demo unit for customer demonstrations and validation. Contact CurrentRF for demonstrations, loaner samples, and other support. CurrentRF maintains offices and facilities in Huntington Beach, California. The company serves commercial and military customers and is ITAR compliant. Thank you very much.